In this video, I am going to teach how to solve CLR parser problem in compiler design. In syntax analyzer, CLR comes under the bottom-up parser. This CLR overcomes the issues in SLR by means of LR of 1 items. In simple LR, we have I0 set that is called LR of 0 items. But in CLR, along with this I0, we need to find the follow elements in each productions that are called look ahead symbols. These are all the steps to follow to solve the CLR parser problem. It almost similar to simple LR, but in each stage we have to find the look ahead symbol and no need to find first and follow elements. The look ahead elements are acts as follow to guide to fill the parsing table. The question can be asked like this. So you should follow these rules. The first step is write an augmented grammar. Augmented grammar is nothing but introducing the new production rule, that is S dash tends to S. Now this grammar is called as G dash. The second step is find the closure function. In this, we need to apply the dot operator at the starting symbol of G dash. So first write S tends to dot capital S. After the dot, capital S is there. So I write this rule also starting with the dot operator. For this rule, after the dot, capital C is there. So I write these two productions also. This is called closure of G dash. Don't add dot operator simply to all the productions. This is called LR of 0 items. Now we need to add look ahead elements for each productions. So LR of items as well as look aheads collectively called LR of 1 items. Let's see how to find the look ahead for these productions. Look ahead is nothing but a following elements. It should be calculated for each and every production. For the first production, capital S is starting symbol, so we add dollar symbol as the look ahead. The second production is formed due to the presence of capital S after the dot. So we should add the follow of the capital S. The follow of the capital S is dollar symbol, so I write dollar symbol here. For this production can be formed from this line. So I need to find the follow of this capital C. The follow element is another capital C. This is the non-terminal. So you should write the first of this capital C. So capital C first is small a and small d. Don't write these two symbols as a comma d because this production rule as well as the look ahead symbols are separated by this comma only. So collection of follow elements can be separated by this R symbol. Then for this line can be formed this capital C only. So we should write the follow of this capital C here. So the follow of capital C is another capital C. The first of capital C is A and D. So in this way you have to find the look ahead symbol for each productions. So this is called LR of 1 items. Now we go to the third step. Third step is nothing but apply the goto functions to I0 set with all the symbols. First I apply capital S. Just follow these rules as we followed in simple LR. After the dot, capital S is there. So I write this production here with the shifting of the dot operator in one position right and write the look ahead as it is. This set is new one, so I named as I1. Then for capital C, after dot, capital C is there. So I write this production here with the shifting of dot operator and write the look ahead as it is in this position. Here, after the dot, capital C is there. So I write these two productions also. But these two productions having different look ahead. So you have to find the look ahead again. So this production can be formed from this capital C. So the follow of capital C is dollar symbol. So I write the dollar symbol here. For this production also can be formed from this capital C. The follow element is dollar. So I write dollar symbol here. For this symbol A, after the dot, small a is there. So I rewrite the production here with the shifting of dot operator and write the previous look ahead as it is in this position. Then after the dot, capital C is there. So I write these two productions. And I need to calculate the new look ahead for this rule. This rule can be formed from this capital C. So I want to find the follow of this capital C. The next elements are small a and small d. So I write these two elements here. For these productions also can be formed from this capital C. The following elements are small a and small d. So this is the new set I named as I3. For the symbol D, this rule is suitable, so I write C tends to D dot with the previous look ahead A or D and named as I4. So repeat this operation for all the resultant sets. Here I1 and I4 are end states, so no need to apply goto functions. I am going to apply the goto functions only I2 and I3. For I2, capital S is not possible because after the dot there is no capital S is there. For capital C, this rule is suitable, so I write S tends to CC dot dollar. This is the new set, so I named as I5. For the symbol small a, this rule is suitable, so I write C tends to A dot C and dollar symbol. For this capital C, I write these two symbols. This production can be formed from this capital C. The follow of this capital C is dollar. So I write dollar here as well as this production also. Here, these two productions are almost similar but different look aheads. So I give the new set name as I6. For the symbol D, I write C tends to D dot dollar. These two sets are almost similar but differ with the look ahead. So this is the new set. So I named as I7. So go to function for I2 is over. Now I am going to do this same operation in I3. So capital S is not possible. So I am going to apply capital C, A and D. For capital C, I write C tends to AC dot and write the previous look ahead ARD. So this is the new set. So I named as I8. For small a, I write C tends to A dot C and the previous look ahead ARD. For this capital C, I write these two productions and this production can be formed from this capital C. The following elements are ARD, so I write ARD as well as this production also. Now these two productions are similar, so I named as I3. For the symbol small d, I write C tends to D dot with the look ahead symbols ARD. So these two sets are same, so I named as I4. So go to functions for I2 and I3 are over. Now I am going to repeat this operation to the resultant sets. I5 is the closed state. So I am going to apply go to functions for I6. For capital C, the result is C tends to AC dot and dollar symbol. This is the new set, so I named as I9. For symbol small a, I write C tends to A dot C dollar. For dot C, I write these two productions. These two productions formed from capital C, follow of capital C is dollar symbol. Now these two sets are similar, so I named as I6. For the symbol small d, C tends to D dot and dollar symbol. And these two sets are similar, so I named as I7. So go to functions for I6 is over, I7 is the end state, I8 is also end state, I9 also end state. So finding the go to functions is over. Here we have repeated sets again and again. So first I remove this one. For this I3 set, we get another I3 set. So I write like this. For this process, we get I4. I4 is already there. So I connect like this. And this I6 with A, we get another I6. So I write like this. In I6 with D, we get I7. So I write like this. So goto function is over. I write this goto function in a tabular format. In your examination, either you write this tabular format or you write this flow diagram. You can do any one, which one is simple to you. So up to this third step is over. Next step is construct the parsing table. For the parsing table, first you identify how many states are available. There are 9 states are available. So write the number 0 to 9 as row values and check what are the terminals available in the grammar. A and D are the terminal. So I write A and D as columns ended with dollar symbol. And capital S and capital C are two non-terminals. So this is the initial stage for constructing CLR parsing table. From the result of goto function, first identify what are the states or non-end states. I0, I2, I3, I6. So using I0 sets only, we are going to fill the 0th row. From the I2 set results only, we are going to fill the second row. So in this way, we have to fill the remaining rows. So first I take the goto function results with I0 symbol. 0 versus capital S, the value is 1, so I write 1 here. 0 versus capital C, the value is 2. 0 versus small a, the value is 3, so I write shift 3 here. 0 versus small d, shift 4. 0th row is over. Now I am going to take the set number 2 results. From this, I2 versus capital S is nil, so I write nothing. I2 versus capital C is 5, so I write 5. I2 versus small a is 6, shift 6. I2 versus small d is 7, shift 7. So second row is over. Now I am going to fill third row. I3 versus capital S is nil value. I3 versus capital C is 8. I3 versus small a is shift 3. I3 versus small d is shift 4. Then the next row is I6. So I am going to fill the sixth row. I6 versus capital S is nil. So I write nothing. I6 with capital C is 9. So I write 9. I6 with small a is 6. So shift 6. I6 with small d is 7. So shift 7. So sixth row is over. First we filled all the values from the non-ending state. Now I am going to identify what are the states or end state. From this result, these 6 states are end states. So these state numbers decides the value present in the particular row in the parsing table. For the explanation purpose, I am writing like this. In your examination, you can directly write the value from the goto function results. For the first row, the starting symbol is going to end. So write the accept value in the dollar column. So this is common for all the grammars. For the fourth row, C tends to D dot. That is, third rule is going to end. So you should write R3 in the A and D columns. For the fifth row, S tends to CC dot. That is, rule number 1 is going to end. So you should write R1 in dollar column. For the seventh row, C tends to D dot. That is, R3 is going to end. So you should write R3 in dollar column. In the eighth row, the second rule, R2, you should write R2 in A and D column. In ninth row, the second rule, that is, you should write R2 in dollar column. So in this way, you should fill the values from the goto functions results. Now 4 steps are over. The next step is stack implementation. The first input string is AAT. In the stack implementation, first we put 0 in stack and given input string ended with dollar symbol. Then compare 0 and A with the table. The value is shift 3. Shift 3 means shifting this A into the stack and also with the value 3. Then compare 3 and A. 3 and A is again shift 3. So after shift 3 we can get this value. Then compare 3 and D. 3 and D is shift 4. After shift 4 we can get this value. Then compare 4 and dollar. In 4 and dollar there is no value. So in the action field you write error. That means the given input string is invalid for this grammar. Then we check the second input. First compare 0 and small d. 0 and small d is shift 4. After shift 4 we can get this value. Then compare 4 and d. 4 and d is reduce 3. Reduce 3 means write the third row. It has only one element, so I select two elements here. So instead of D4, I write capital C. Compare 0 and C. 0 and capital C is 2, so I write 2 here. Compare 2 and D. 2 and D is shift 7. After shift 7, we can get this value. Then compare 7 and dollar. 7 and dollar is reduce 3. Reduce 3 means C tends to D. So for the one element, I remove two elements here. Instead of D7, I write capital C. Then compare 2 and C. 2 and capital C is 5. So I write 5 here. Then compare 5 and dollar. 5 and dollar is reduce 1. Reduce 1 means write the first rule. Here two elements are there. So we should eliminate 4 elements here. So instead of these 4, write capital S. Then compare 0 and S. 0 and S is 1. So compare 1 and dollar. 1 and dollar is accept. That means the given input string is valid for this grammar. In your examination, you can verify your answer by the following shortcut method. Before doing the stack implementation process, you should cross-check whether the given input string is valid or not by manually. Try to reduce the given input string into starting symbol capital S. If I try this small d can be reduced into capital C. This A and C collectively reduced into capital C. This AC can be reduced into capital C. So we cannot reach capital S. So the first input string is invalid. In the same way, I try to reduce the second input string into starting symbol capital S. This D can be reduced into capital C. This D can be reduced into capital C. These two values can be reduced into capital S. So before doing this stack implementation, you can ensure the particular input string valid or not, and then do this stack implementation process. So in this way, you can solve this problem in your examination. If you have any queries, make it as comment.